Welcome to The Explainer. Today we're jumping right into the heart of the factory floor to talk about something called Statistical Process Control, or SPC. It's all about quality. We're going to look at the old way versus the new way, and trust me, it's a total game changer.
So let me ask you this. Is your quality data actually fast enough to stop a problem before it happens? I mean, that's the big challenge in manufacturing today, right? It's a race against time. If your process starts to go off the rails, how fast can you catch it? Because if you're slow, you're talking about waste, you're talking about rework, and that's expensive. It really all boils down to one thing. How fast is your data?
All right, so here's what we've got on tap. We'll start with the challenge itself, then dive into the old-school offline SPC. After that, we'll check out modern online SPC, compare them side by side, and then we'll even peek under the hood to see how these new systems really work. Let's get into it.
Okay, first up, the traditional way of doing things, the manual method. This is the classic approach that, a lot of places have been using for decades.
So what exactly is offline SPC? Well, it's when you collect and analyze all your data manually, after the fact. The key word there is after. It's not connected to the production line in real time at all. I love this analogy. It's kind of like trying to navigate rush hour traffic using a map from yesterday. You're always playing catch-up.
And you can really see that lag in action here. Step 1, an operator on the floor has to manually measure something. Then they got to write it down on paper or maybe save it to a thumb drive. Later, and I mean way later, someone has to key all that data into a computer. By the time an engineer actually gets to analyze it, they've spent most of their time just wrangling the data. And here's the kicker. By the time they find a problem, you might have already made thousands of bad parts. Ouch.
All right, so now let's flip the coin and look at the modern way, the automated upgrade. This is where things get really exciting and honestly a lot more responsive. So what's Online SPC? It's the polar opposite. It's a fully automated system where data is collected and analyzed in real time. It's all happening through direct connections to the machines. This just completely flips the script. The analysis isn't happening in an office somewhere hours later. No, it's happening right there on the line as the part is being made. It's all about catching issues the very second they start to appear.
Just look at the difference here. The machine's own sensors grab the data instantly. Poof! It's sent over the network to a central server. The system then crunches the numbers in real time, checking for any little deviation, using all those fancy statistical rules. And if it spots anything at all, bam, an alert goes out to the operator in seconds. This is how you stop bad parts from ever being made in the first place.
Okay, so let's put these two head-to-head. The old school versus the new school. Here's the full comparison.
This table really lays it all out, doesn't it? Look at reaction speed. We're talking seconds for online versus hours or even days for offline. Labor, online is automated, offline is super manual. And the warning capability, this is a big one. Online is proactive, it predicts issues. Offline is reactive, it just tells you about problems you already had. Now there is a catch. The implementation cost for online is higher for sure. But the offline method, while cheaper up front, is just slow and disconnected.
And this quote right here, this just says it all. In the past, engineers spent 80% of their time organizing data and only 20% analyzing it. Online systems flip that ratio. Think about that for a second. This isn't just about faster computers. This is about freeing up your smartest people to do what you actually hired them to do: solve problems, innovate, and make things better, instead of just being data entry clerks. It's a huge shift in how you use your talent.
So you might be thinking, okay, this real-time stuff sounds great, but how does it actually work without grinding the whole factory to a halt? That's a great question. Let's take a quick look under the hood.
So, it all starts with the data flowing from the machines on the factory floor. It gets sent straight to what you can think of as the central brain of the whole operation, the Manufacturing Execution System, or MES.
Now here's the really smart part. The MES has a lot to do. So to keep it from getting bogged down, it doesn't do all the heavy number crunching itself. Instead, it sends that process data over to a dedicated SPC server to do the hard work.
And this separation is absolutely critical. Think of it like this. The MES server is the air traffic controller, right? Its job is to keep things moving fast. Track products, manage equipment. That's it. The SPC server, on the other hand, is the deep dive analyst. It's looking at historical trends, checking against control limits, doing all the complex math. By splitting up the jobs, you make sure the analysis never, ever creates a traffic jam on the production line. It's a brilliant setup, especially for really high-speed manufacturing.
And to finish the loop, once the SPC server has its answer, it doesn't send back a mountain of data. Nope, it just sends a simple, direct command back to the MES. Something like, hold this slot, or everything's good, pass it through. The MES then tells the operator exactly what needs to be done. It's a perfect closed-loop system.
So let's bring it all home. Why does all this matter? Well, the bottom line is this. It's about preventing defects instead of just finding them later. That means less waste, which means lower costs. It frees up your best people to do more valuable work. And really, it's what enables a truly data-driven factory, not just one that collects data.
So the big question to leave you with is your factory ready to operate in real time? You know, the choice really does depend on your specific situation. But let's be honest, the direction everything is heading is crystal clear. As manufacturing gets smarter, faster, and more competitive, being able to act in real time, well, that's quickly moving from a nice-to-have to an absolute necessity.